Bismillahirrahmanirrahim. In this video, we'll solve question number 6.1, which is an end chapter problem. Now, before we solve the actual problem, let's clarify our concept about the cutoff mode, active mode, and saturation mode. We have seen this earlier as well. Now, for NPN transistor, this is N, then P, and then M material. And if the P and N, or the base or emitter, is reversed biased, like here, so for P we have connected negative, and with N we have connected positive. This means this is reverse bias. So when VBE is a reverse bias, no electron can flow through the circuit, and therefore this is for sure in cutoff mode. So this we have to keep in mind. However, to complete the action, we also say that the base and collector junction is also reverse bias, and so here also for collector, which is N type, we connect the P of the battery, positive of the battery, and with P we connect the negative of the battery. So this is also reverse bias. So when both are reverse bias, that is fine, but even if the collector base junction is reverse bias, then the transistor will be in cutoff mode because no electron can flow through this. Now let's see the other two. Now let's first of all see the base and emitter relation. Now in the base and emitter, battery is connected opposite of what was connected here. That means the positive is connected with the P and negative is connected with the N. So therefore this is forward bias, and same here. So when the base emitter junction is forward bias, the electrons will flow from emitter to the base. In both cases, electrons will flow from emitter to base. Now see the difference between the two here. Now in this case, this is also forward bias because the negative is connected with the negative and positive is connected with the positive. So the collector base is also forward bias. So the electrons coming from here will have absolutely no resistance, and they can very easily flow through this circuit. And therefore this circuit is called that this carries maximum current and it is in saturation mode. So this is saturation mode. However, here the situation is different. The electrons have already reached at this point, but this is a reverse bias. The collector base junction is a reverse bias because with the N type we have connected P of the battery, and with the P we have connected N of the battery. So this is a reverse bias. But electrons are already here, so they'll push through this barrier and will complete the circuit, but it will not be an easy flow as it was in case of saturation. So this will be a difficult flow, and this is called active mode. So the difference between the two should be clear now. The base emitter is forward bias in both the case. Irrespective of what is the voltage here, or what is the voltage between the two, whether it is positive, it is negative, or it is zero, electrons will flow. But if it is reverse bias, the electrons will flow gradually. But if it is forward bias, as it is here, the maximum number of electrons will flow. So this is saturation mode, and this is active mode. Now let's solve the question. So this note here, for active mode, VBE has to be forward biased or greater than 0, and VCB could be greater than 0, or it could be equal to 0. So even if this is 0, this battery, still it will be in the active mode. Okay, now the question is, the terminal voltage of various NPN transistors are measured during operation in their respective circuits with the following results. Okay, so these are the results, the voltage uh, E and B and C, and 0 indicates the reference terminal to which the black or the negative probe of the multimeter was connected. So we are measuring these voltages with the help of multimeter. So let's see the first one. For each case, the question is, for each case, identify the mode of operation of the transistor. So let's take the first case. Okay, the circuit we already studied, but we'll keep for reference. So in the first case, emitter voltage is 0, or this is the reference. The base voltage is 0.7 volt, and the collector voltage is also 0.7 volt. So now we have to determine whether it is cutoff mode, active mode, saturation mode. Okay, so let's go one step further. Now since this is 0.7 and this is 0, so we can place a battery here with the positive terminal at the top and negative at the bottom. Similarly, this is 7 and this is also 7. So we can say that we have a 0 volt battery in between the two. And so this is applied here, that the active mode VBE has to be greater than 0, which it is, and VCB can be greater than 0 or equal to 0. So here VCB is 0. So this is active mode, and from the diagram we can just correlate this with this. So this is the active mode operation. Now let's see case number 2. 0, 0.8 and 0.1. So 0, 0.8 and 0.1. Again, I will draw the battery. So this is higher potential, so we have the positive of the battery. But this is at lower potential with respect to this. So we'll have opposite battery. So the negative at the top and positive at the bottom. And now if we compare this with the circuits given here, so between the two, the both are forward bias, but the CB is negative in this case. So CB is negative at the top. That means it is also forward biasing. So this is the circuit that is matching with this one. So we can say that we are in saturation mode. Okay, now let's take case number 3. So we have minus 0.70 and 1. So this is how it will look like. Minus 0.7 at the emitter, 0 at the base, and 1 volt at the collector. And now let's connect our battery. So since this is negative and this is 0 at higher potential, so we have to connect a battery like this, positive at the top, negative here, and since this is 1 and this is 0, so again a positive of the battery at the top and negative at the base side. So this will now look like, let's see, this circuit here, this battery, and similarly the battery. So this is the active mode case. So we can say that case number 3 is an active mode. Now let's go to case number 4, minus 7, 0, but this is now minus 6. Okay, so minus 7, 0, and minus 6 at the collector. So again we correct the batteries, so this one remains same, but here now the battery reverses because this is negative 6, so the negative will come at the top and positive at the bottom. And now let's compare this diagram. So this will be matching with this diagram, so which is the case of a saturation mode. And Finally, we come to case number 5. So case number 5, 1.3, 2 and 5. So 1.3, 2 and 5. And there is no reference in this case, so the reference may be somewhere here, ground. But anyway, we can see that this is at the lowest potential, then is base terminal, and then is the collector terminal. So we can again connect our batteries. This is lowest, so it will be 0. This is higher than that, so it will be positive. Between these two, this is higher, so it will be positive, and negative on this side. So now again, if you compare, this is matching the active mode circuit. So this is an active mode. And finally, case number 6, 0, 0 and 5. So 0, 0 and 5. Now since we have learned also earlier that the base has to be at a higher potential, at least 0.7 volt, only then base emitter junction will be forward biased and electrons will start flow. But since these are in the same potential, therefore there will be no flow of electron, and we can say that this is at the higher potential than this with 0 volt battery, or the battery is 0 volt, so they are at the same potential. So as we said, this has to be higher 0.7 volt, only then this will be forward bias. So now this is reverse bias, so we can show it with the battery of reverse bias, and this is a battery positive at the top and negative at the bottom. Now if you compare, this looks like this one here. So this is a cutoff mode. So we can conclude that our result should look like this. The first case is active, then is saturation. Third case is active, fourth saturation, fifth active, and sixth cutoff. So I hope this gives you an understanding as to how to find the mode from the voltage terminals given. Thank you.